Lesson, we're going to focus on trigonometry. Specifically, our focus for today is right triangle trigonometry. The objectives is to write 3 trig ratios for any given angle in a right triangle, but also to be able to use trig functions to evaluate missing sides or missing angles. Let's first start off by looking at the 3 trigonometric ratios. The 3 trigonometric ratios that we're referring to are what's called sine, cosine, and tangent. These are the 3 trig functions that we're going to be able to use to help us solve for missing sides and angles. If we're given a right triangle in math, so remember for a right triangle, there has to be one of the angles being a right angle here. But if we're given some angle in that right triangle, in relationship to that angle, we identify some key sides in a right triangle. We have one side, which is called the hypotenuse, and hypotenuse is always opposite that right angle. It's always the longest side as well. We have another side that we call the opposite, and the opposite is the furthest away from that angle. And then the last side we call is the adjacent side. That's the word next to. And what I want you to notice is the angle is always created by the hypotenuse and the adjacent side. It will never be created by the opposite and hypotenuse side. So whenever we're given a right triangle and a given angle in that right triangle, the first thing we want to do is identify those sides. We want to identify the opposite, hypotenuse, and the adjacent side. Once we've identified those missing sides, it is true that the sine of the angle, now we use this little notation to represent an angle. Okay, that's called theta. It's a Greek letter. But use sine of whatever that angle is going to be equal to the proportion of the opposite side over the hypotenuse, so whatever those lengths are. And so if you, on your calculator, take the sine, and I'll show you that here in a little bit where that's on your calculator, but if you take the sine of whatever that angle is, let's say 43 degrees, it's going to be equal to those opposite over hypotenuse sides as a ratio. Okay. It is also true that the cosine of any angle is equivalent to the adjacent side over the hypotenuse. And lastly, the tangent of any angle is equivalent to the opposite side over the adjacent side. So we have a little acronym to help us remember these, and you guys might have heard it before, but we use what's called TOA, where the S represents sine, the C represents cosine, and the T represents tangent. And this nice little acronym, TOA, helps us remember these ratios, that the sine is the opposite over hypotenuse, the cosine there is the adjacent over hypotenuse, and then that tangent is the opposite side divided by the adjacent. And so it's in order, and so we say TOA to help us remember these 3 trig ratios. But somewhere in your notes, you should at least copy this slide down, especially the right triangle and the acronym TOA, but more specifically, these are the important ratios that we're going to be using today to not only set up the ratios, but again, to solve for missing sides and missing angles. So let's first get used to just representing these ratios, okay? So here we got a right triangle. We have the missing sides, or we have all the sides identified in here. If you had a missing side in this case, you might have to use the Pythagorean theorem. If you remember Pythagorean theorem is a squared plus b squared equals c squared, where your c is the hypotenuse side. So if you're ever missing a side, you may have to do that ahead of time. But notice we have everything here for us. So first few questions we're going to look at is, we're just going to look at angle C for now and write the ratios for angle C. Well, notice angle C is in the upper left corner here. So I'm going to mark where that angle is. Once we've identified the angle's perspective, we're going to identify the sides on the right triangle. And remember, the sides that we're looking for is the opposite hypotenuse and the adjacent sides. So I'm going to put an O, A, and H to represent those sides here. Well, remember the hypotenuse is always the longest side, so that has to be that length 25 there. So I'm going to put an H to represent the hypotenuse. Remember the angle that's given, which is angle C here, that's always created by two sides, and specifically the adjacent and hypotenuse side. So that means that 7 there has to be the adjacent side, which means the 24, which is the furthest away from that angle, that's going to be identified the opposite, so we're going to use an O. So we've identified our three sides. Now we're going to write the sine of C, cosine of C, and tangent of C as ratios, as fractions. If you can reduce, reduce. If not, it's just a fraction. That's our answer. So remember that the sine of any angle is the opposite over hypotenuse. Okay, so if I wanted to find the sine of C, the opposite side, which has length 24, over the hypotenuse side, which has length 25, we cannot reduce, so the answer for the first one would be 24 over 25, and that's a ratio. The cosine of any angle, remember, is the adjacent over hypotenuse. So in this case, we'd say the cosine of angle C is the adjacent side, which is 7, divided by the hypotenuse, which is 25. Again, we cannot reduce, so 7 over 25 would be the cosine of C. And then lastly, the tangent of any angle, remember, is the opposite over adjacent. And so in this case, if I wanted to find the tangent of C, the opposite side is given as 24, the adjacent side is given as 7, and again, we cannot reduce, so 24 over 7 would be my ratio for tangent C. So now let's take a look at the other three, which is now we're looking at where angle T is. So now from T's perspective, which is in the lower right-hand corner here, we need to relabel our sides. And the only two sides we need to relabel is the opposite and adjacent side. The hypotenuse is always going to stay as the longest side, which in this case is, again, 25. But notice when I put my angle in the right-hand corner now, the opposite side is going to be the length 7 side, so we're going to put an O there, and the adjacent side now is going to be the length of 24. So it does change based off where your angle is. So now if I set up my ratios and I wanted to find the sine of T, again, it's still opposite over hypotenuse, but in this case, it's going to be that 7 divided by the 25 here. And again, we can't reduce, so 7 over 25. And so if I find the cosine of T, again, it's still that adjacent over hypotenuse side, but now the adjacent side is 24 and the hypotenuse is 25. So the cosine of T would be 24 over 25. And then lastly, tangent of T is opposite over adjacent. And so in this case, it's going to be 7 over 24. And again, we can't reduce. So 7 over 24 is our answer. So take a moment and see if you can try this one on your own. All I want you to do is represent the three trig ratios, so just set them up as fractions, and notice we're referring to angle B here. So remember to first identify your sides. Once you've identified your sides, remember TOA is going to help you remember the ratios, right? So good luck. You can pause the video and try your best, and we'll go over these here in a few seconds. So for the first one, remember the first step is to identify the sides. So that length 37 there is the longest side, so that has to be your hypotenuse. So we're going to label it H. Remember the angle is always created by the adjacent and hypotenuse sides. And so that means that 35 there has to be your A side. And the farthest away side, which is this 12, that's our opposite. So we've identified our opposite, adjacent, and hypotenuse. Now we need to find those ratios. And remember to find the sine of any angle, that's the opposite over hypotenuse. So in this case, the sine of B, well, the opposite side is 12. The hypotenuse is 37. We cannot reduce. So you should have got 12 over 37 for sine of B. Cosine of any angle, if you look at SOH, that's the adjacent over hypotenuse there. So that's A over H. So in our case, the cosine of B is going to be the length 35 there over the hypotenuse, which is 37. Again, we cannot reduce. So 35 over 37 is our final answer there. And lastly, to find the tangent, which our SOH means opposite over adjacent there. And so tangent of B is going to be the opposite side, which is 12, over the adjacent, which is 35. Again, we can't reduce, so 12 over 35 would be our ratio. So now that we know how to set the ratios up, once we set up a ratio, now we can then use it to find for missing sides or missing angles. So the first part here we're going to look at is several problems involving missing sides, where you try to solve for a side, and the other last part of today's lesson is looking at when you're missing an angle. When you're missing sides, the very first thing to do is decide what trig function you need to use. Okay, so I'm going to write out SOH here to help me out. So I'm either going to use sine, I'm either going to use cosine, or I'm either going to use that tangent ratio to help me solve here. When you look at the triangle, it's important that we identify the sides. Okay, so here's where my angle is located. That's 37 degrees. From that angle, the opposite side is farthest away. That's going to be the length x there. The hypotenuse, notice, is opposite the right angle. That's the longest side. That has nothing there for us. The hypotenuse is sort of a blank side there, but I'm going to put an h. And then notice that other missing, or that other side, length 12, that would be our adjacent side. So I've identified the sides. Once you've identified the sides, notice that we're solving for the opposite and we're given the adjacent. We have nothing. In fact, the hypotenuse, there's nothing there for us. It's a blank side. So that means in my trig ratios, I'm not going to need anything with hypotenuse in the ratio. I'm not going to need anything with h in it. So if I look at SOH, since my hypotenuse is blank, then that means I'm not going to use any equation with h in it. So that rules out sine, that rules out cosine, because both of those equations have h in it. There it is. That tells me that here I'm going to use tangent. The first step is to always write out what the formula is. We know the tangent of any angle is the opposite over adjacent, and then the next step is to sub in the known information. Tangent of, we have a given angle here, so I'm going to sub directly that 37 degrees in for theta, equals the opposite side, which is x, we don't know that, divided by the adjacent side, which is 12. Once you've set up the ratio here, right, we plugged in our known values, now our job is to solve for x. Notice x is on top on the right-hand side, so in order to get rid of that 12 here, we would have to multiply 12 to both sides. It's going to cancel the 12 on the right side, and what you're left with is x equals, well, I guess it's going to be 12 times that tangent of 37. This is the stage where we would enter this on our calculator. Now, if I were to enter this on my calculator, the very first thing you got to check is that you're in the correct mode. Okay? And so to enter these on your calculator, if you press the mode button, which is right next to the second key, you need to make sure that you are in degree mode. Okay? I know that in previous lessons we looked at graphing calculator, like prerequisite skills, that your mode has to be everything to the left. But for these problems specifically today and through the rest of this unit, you need to make sure it's in degree mode. So I'm going to make sure I highlight degree and press enter so that it's highlighted. Now I know I'm in degree mode. Once I'm in degree mode, if you go second mode, so second mode, it quits, gets back to your calculator page, and now I'm going to type this in. 12 times, now notice the tangent button, the sine, cosine, and tangent buttons are directly above the number keys. In fact, there's a, looks like a comma and a couple parentheses. Right above those is going to be your three trig function. So I'm going to press the tangent button, okay? And then I'm going to enter in the angle right next to it. So tangent of 37, and I'm going to close that parentheses. So that's what it looks like on my calculator screen. 12 times tangent, and then in parentheses, 37. If I press enter here, it's going to give me what that length was. So our answer here, if I did one decimal place, would be 9.7. I guess let's say 2 decimal places, 0.4, and that would be my answer. So let's take a look at a few more here. So here's another one. Again, if we follow our steps, the very first step is let's mark those sides out. So here the angle is given as the left-hand corner here. From that angle, notice the x length, that's the hypotenuse side because that's the diagonal length. That's the longest length. It's always opposite the right angle, so that's going to be our hypotenuse. Remember, the angle is always created by the hypotenuse in the adjacent side, so that must mean this blank side is the adjacent. In this length 16, which is farthest away from the angle, that's our opposite. Now to figure out what trig function you use, let's write out SOH. And just like that last problem, notice the side that's blank here. Notice the side that doesn't have x or a number on it. And if you look at it, specifically the adjacent side, right? The adjacent side has nothing on it, right? We don't know what that length is. We're not trying to find that length. So that means we don't need anything with a in it in our formula. So that rules out cosine, and that also rules out tangent. So it tells me here I'm going to use the SO, which represents sine. The sine of the angle is the opposite over hypotenuse. So if I sub everything in here, so that'd be the sine of 63 degrees is my angle. The opposite side is 16, and the hypotenuse is x. So if you remember in the last example, x was on top where we'd be able to multiply that number to both sides to be able to get rid of it. Here we have x on the bottom. And a trick shortcut, I mean, to solve this, you'd actually have to multiply x to both sides, then divide by that sine of 63. But in short, sort of a trick here is anytime you have that x on the bottom, if you simply just switch these two positions, that's what x is going to equal. So if I switch these, it will become x equals 16 over the sine of 63, and this is what I would type on my calculator. 16 divided by the sine of 63. So if I bring up my calculator here again, you want to make sure you're in the right mode. We're in degree mode. We should still be in degree mode here, but I'm going to double check. Mode. Yep, I'm still in degree mode. Now I'm going to type this in. So 16 divided by, and the sine is right above, a couple keys above 7. So if I press that sin button, and then in parentheses 63, close the parentheses, should give me my right answer here. So there we go. So it looks like x equals 17.96 if I do 2 decimal places. So here's your chance to try a couple before we move on to the last part of today's lesson, which is on solving angles. But take a moment, pause the video, try the best you can on here, and we'll go over these here in a few seconds. Good luck. So for the first one, if we look at where the angle is here, the sides are in relationship to that angle. That 22 should have been the hypotenuse. The missing side would be our adjacent, and then what we're solving for, that's the opposite side. So notice, again, if I write my SOH above here, it's going to tell me what trig function to use. Notice my adjacent side, again, is the side with the blank on it, so I'm not going to use anything with a in it, right? So that means it rules out cosine, and it also rules out tangent. So again, it looks like we're going to be using sine here for the first one. So if I set up my equation, it'd be the sine of the angle equals opposite over hypotenuse. In this case, it's the sine of 43 equals the opposite, which is x, over the hypotenuse, which is 22. Here, the number's on the bottom, so to get rid of it, we can multiply 22 to both sides. Cancels on the right, and what you're left with is x is going to equal 22 times the sine of 43. So if I bring up my calculator here and type that in, so looks like it's going to be 22 times the sine of 43. Press enter. And so there we go. So we get about 15 exactly if I did 2 decimal places there. So x equals 15. So in the next one, here are the angles in the lower left-hand corner. So in relationship to that angle, that 6 there is going to be our adjacent. The opposite side is going to be farthest away. That's the x there, and so that must mean that blank side is hypotenuse. So if I draw out my SOH here, notice the blank side in this case is the hypotenuse. There's nothing there for us. We're not solving for a hypotenuse, and I mean that length isn't even given. So we're not going to use anything with h in it in this case. So that rules out sine, that rules out cosine. There we go. It looks like we're using tangent here. So if I write out my formula, tangent of the angle, opposite over adjacent, tangent of 23, whoops, there we go, equals the opposite over adjacent, so x over 6, and then notice, again, the 6 is on the bottom, so to get rid of it, I've multiplied to both sides, and so x is going to equal 6 times the tangent of 23. And so if I pull up my calculator here now, so 6 times tangent of 23 in parentheses, enter. So about 2.55 if I did 2 decimal places here. There's my answer. So last part is looking at solving for angles here. With solving for angles, the first couple steps are similar. You still want to find those missing sides. We want to identify what trig function we're going to use, and then now we're solving for an angle. So this is when we use the second sine or second cosine or second tangent of this on my calculator. And those are called the inverse trig functions. But let's first take a look at this together. So notice the angle that we're trying to solve is x. It's in this upper left-hand corner. This is the angle where we want to solve, so now we want to identify our sides. The diagonal length there of 25, that represents your hypotenuse. The angle, remember, is always created by the adjacent and hypotenuse, so that means that's 18 there, has to be the adjacent side, which means the blank side is the O. Just like before, if I write out SOH to help us determine what trig function you use, notice the blank side here is this opposite side. We have nothing there. It's blank. So then that means I don't need anything with O in it. There we go. I need to use cosine here. So if I set up my equation, cosine of any angle equals the adjacent over hypotenuse. Here, my theta is just x, so I'm going to represent it as x. So cosine of x equals the adjacent side, which is 18, over the hypotenuse, which is 25. Now, any time you're solving for an angle, that's when we use what's called the inverse trig functions. So once you set it up, the next step is that it's true that x is going to equal the cosine inverse of 18 over 25. And we use this little to the -1 to represent the inverse. Remember, we talked about inverses of functions, quarter 1. It has a similar notation. We have that little -1 power there to represent the inverse. So to do this on your calculator now, you just need to press the second button, which is the blue key, right before you enter cosine. So to do this, if I press the second button, which is right below y equals, and then now press the cosine button, which is right above the left parenthesis, you'll see that cosine -1 appear. So second cosine, and then typing in that fraction, 18 divided by 25, closing my parenthesis. That's how it looks on my calculator, and if I press enter, there it gives me. And again, you have to be in the right mode, and I'm in degree mode still, but this tells me that that angle was 43.9 degrees. And so x equals 43.9 degrees, and that would be my answer here. So let's take a look at a couple more here. So here the angle, notice, is in the upper right-hand corner. So now if I identify my sides, that length 21 here is going to be the hypotenuse because that's opposite the right angle. The opposite side is going to be that 13 because that's the farthest away. So that's O, and then so notice the adjacent side is missing. So since the adjacent side has nothing on it, that means I'm going to need nothing with A in it. So that tells me it looks like sine is my trig function here. So if I set up my equation, sine of the angle, opposite over hypotenuse, sine of x, x is our angle that we're solving for, opposite side is 13, hypotenuse is 21, and now in this case, to solve for x, we're going to use the sine inverse of that ratio. So now on my calculator, I just need to type in sine inverse, which is second sine, and then enter that fraction in, and it should give me my answer. So second sine pops up that sine inverse, and then 13 divided by 21, closing that parenthesis, pressing enter. There we go. So it looks like my angle here was roughly 38.25 degrees, if I did 2 decimal places there. So now it's your turn to try to see if you can find these missing angles that has the question mark there. So take a moment, pause the video, and try the best you can, and we'll go over these here in a few seconds. Good luck. So for the first one, looks like my angle is here in this upper left-hand corner. In relationship to that angle, the hypotenuse would be the 54. The 51, which is the farthest away, that's going to be your O, opposite, and then notice the adjacent. The adjacent is nothing on it right there. So in my trig equation, I'm not going to need anything with A in it because the adjacent side is all blank. So this tells me in the first one you should have used sine. So if I sub in my formula, it's the sine is opposite over hypotenuse. Sine of we don't know, you can write it as x or you can write it as question mark, doesn't matter. But the opposite side is 51. The hypotenuse is 54. So to find that missing angle, if I take the sine inverse of that fraction, that should give me my answer here. So bringing up my calculator now. So to type this in, I need to go second sine, and now 51 divided by 54. Close the parenthesis, press enter. There we go. So it looks like in the first one we got 70.8 would be my angle here. So 70.8 degrees. All right, so for the next one now, notice the angles again in the lower left-hand corner, but in relationship to that angle, this 56 side would be your hypotenuse, and remember the angle is always created by adjacent hypotenuse, so that means that 52 length has to be the adjacent. So the O is what's blank here. So in my TOA, since the opposite has nothing on it for us to use, then we're going to not need anything with O in it. Cosine here. So if I set it up, cosine of my angle, adjacent over hypotenuse, cosine of, we'll call it question mark. The adjacent side is 52, the hypotenuse is 56, so in order to solve for that, if I take the cosine inverse of that ratio, that will give me that answer here. So I'll bring up my calculator here. So now we have to do second cosine to get that cosine inverse up. So second cosine, and now it's 52 divided by the 56. And if I press enter, there you go. You should have got about 21.8 degrees. So hopefully you got both of those answers. But for now, you can check out the practice out there on Canvas. I know this was a longer lesson, but hopefully you got a little taste of it in geometry last year. But you can go ahead and practice the problems out there in the practice, and then don't forget